Insulated rubber,
Rubber,
plastic.
plastic, glass. Okay, perfect. So what did we leave on last time? The 5 principles of electrostatics. Okay, so do you guys remember number 3 and number 4, which was something new?
Bless you.
Yes.
Yeah.
Okay. So what do I mean by number 4?
The
Move
pole.
the curvature, the
The
move
pole
the
curve on the surface.
Yes, so electrons tend to accumulate where the curve is the greatest. Okay. All right, so in electrostatics, electrification of objects happen only when there's a net positive or a net negative charge. So, for example, I use the person like rubbing a balloon on their hair. So the process of making that neutral body, which is the person, into a charged body is electrification. Okay? And there's 3 ways that you can electrify something: friction, contact, or induction. And induction is a process by which an uncharged metallic object, could be any metallic object, experiences a shift in the electrons when it's brought into the electric field of a charged object, and we'll go into what that means.
So
in
it's
the next
like-
couple of slides.
It's like ionization or ion pairs, like pulling something else into it.
Kind of like that, yes. If you're confused, don't worry, I'll explain what it means. Can I move on?
Oh, hold on. Uno momento.
I got pictures if you want me to send them too. I was saying I got pictures
Did
if
you
you
say
want me
uno
to.
poquito?
No,
In the
uno
middle.
momento. Oh.
A little small. Oh my god, you guys. Of course. Do you need it or?
So friction is when you, for example, when you're walking across carpet, right? Or if you rub a balloon on your hair, that's friction, right? Contact is, for example, when you go to reach the handle of the door and you get that little spark. And then I'll go over what induction means in just a second.
So friction, stripping of electrons, contact,
Well, in
contacting.
all 3 scenarios, electrons have been moved from one object to the next object for it to be electrified. Just know that these 3 are the different processes. That's friction. Contact is when you like go to touch a door handle, and there's a transfer of electrons and you get shocked. That's all.
You know, you can go very slow on this, that's not so marquee.
I know.
So take your.
Sounds like a lot of review days.
Sounds like a lot of worksheet days.
You say.
I'll show you with the video. Sometimes it's better to see it rather than me explain it. Alright, now I'm gonna move on. So, going over what those 3 are again. Friction. When an object is rubbed against another, electrons travel from one object to the other, producing a charge. For example, rubbing a balloon on your hair, or walking on carpet with socks on. Contact. When 2 objects touch, electrons move from one to the other. Both objects have the same charge after the contact. For example, touching a door handle. And then induction is the process of using electrical field of a charged object. For example, this thing here has a negative charge, and when it's brought near this metal sphere, you see how the negative parts go away from it? Because like charges repel each other. Okay? I'll show y'all a video. Where's my video? Oh, right there.
Are we gonna do any like activities with regard to this or?
No,
This is Dave. Hey, Bonilla, shut your mouth. And I bring you to you.
Good thing Grammarly's tone suggestions can help move things forward.
Here in this demo, we're going to charge these two spheres by induction. So, the two spheres are the piece of metal. And we have them touching right now. And electrons can easily move from one to the other when they're touching. So it's essentially one piece of metal.
You want
Later when we move them,
sometimes-
that's a way to cut them.
Yes.
That way to cut them, we just have to separate them like that. So when they're touching, the conductance across that gap is pretty good. So think of it as one piece of metal. I'm gonna bring my Teflon rod, charge it with fur, bring it close, and it's gonna create a separation between the charges.
So he's charging that rod right now.
So if I do this, there's a
Don't
negative
foul.
charge right here. It's pushing negative charge over here. It's leaving positive charge over there. You didn't see anything. Well, there's nothing. So let me charge it up again. Bring it over here. And now I'm going to cut. I'm going to separate them. And now we just charged the two spheres by induction. Of course, you can't see it. I'm going to try to prove it to you with a little bit of Teflon tape. And so we know if we rub fur on this Teflon tape, we know it ends up negative. So if this thing ends up negative, then they should repel each other. Or the tape should be repelled. Sure enough,
That's
you see
cool.
the tape is repelled. Doesn't want to touch the metal. And we should have left the other one positive open. And sure enough, it's positive. It's very sticky for the tape. We use our Teflon rod, or our Teflon tape to confirm it really did what it was supposed to do. Repulsion. There's one other way we can confirm it, is when I bring them together, if you look very close, you can see a spark jump across the gap. The negative charge, the positive charge comes back together, makes a corona and an arc like we talked about before, and you can actually see the charge go back. So seeing is believing.
I appreciate that zoom.
Charging by induction. It's also not a
So that
quantitative
was
thing like
charging by induction.
the amount of charge.
Might be
And we
good.
didn't
Was that
twist around.
easy to understand now?
For now, it's just another way to think about.
So
Basically, when you bring a charged object into the field of the uncharged, or not uncharged, but a metal object, the electrons tend to go to the opposite side because they repel each other. Okay, take a look at that image.
So does that mean that the positive ones they flow towards it?
The positive is attracted to it, so it'll stay right there to the surface. The electrons will be on the opposite side. That's why when you brought that Teflon
Tape?
tape to the other side, remember it was repelling, but on the other side it was not.
You can do the same thing with like cheap stuff. If you take a balloon and rub it against your hair and then like a plastic bag, you can hold the plastic bag over the balloon and it'll float in the air.
Really?
Mm-hmm.
Ooh, bring it next time.
So basically,
Oh no, we're not doing activities, remember?
Say that again, Jay?
Say what again?
Whatever you just said about the balloon.
If you take a balloon and inductively charge it, and then you take a strip of like a plastic bag and hold it above the balloon, it'll just float in the air after, because both are negative.
Class activity next time.
Oh no, we're not doing it, right?
Well,
That's what I was trying to get to, and you shut me down.
No, I thought you meant did I have an activity planned? But yes, if y'all would like to do that, then let me know. Okay, so in an X-ray circuit or any circuit within electricity, in order for electrons to flow within a conductor, there has to be what we call electric potential. And what we mean by electric potential is the ability to do work, right? So, in order for an electric potential to exist, we need to separate those charges from positives to negatives, separate them. So we would want the positive charge on one end and the negative charge on the other end. Like you guys saw with the video, induction, remember the electrons go to the opposite end to try to get away from the charge. So that's exactly what needs to happen with separate the charges. Battery has a positive and negative side, just like an X-ray tube, and in the middle we have an electrolyte solution. So that's kind of a chemical solution that allows the negative charge to separate from the positive charge. And so the electrons would go from the negative all the way through the circuit, lighting that light bulb, and then coming back to the positive. Because they want to be attracted to the positives, right? So once that separation happens, what they do is travel from the negative side all the way through the circuit and come back to the positive. So it's like a constant flow of electrons, and that's how we get electricity.
So are the electrons coming from the negative side or from the positive side?
From the negative side,
Mhm.
and they flow all the way back to positive.
So all of the energy from a battery is in that tiny little like zinc casing at the bottom, or is it the paste? Like how is the battery actually storing the charge? Is it from the thick paste of chemicals, or is it from the? Because okay.
It's from the thick base of chemicals. Yes.
Okay.
Question.
Yes.
So you said the electrons, like you got it written there, they flow from the negative side to the
To the
light bulb?
positive. Mhm.
To the positive, and then just keep going in that
So
flow.
they're constantly flowing from here to here,
Okay.
here to here. That's how we have electricity.
But
Yes.
the electrons only flow from the negative side to
To
the
the
positive
positive.
side by having the electric potential.
Yes. So electric potential is a separation of those charges. So in order for us to have electricity, electric potential has to exist. If the charges are not separated, electrons are not going to flow, correct? That's why this needs to exist.
Since
Electric potential is the separation of the charges,
Yes,
like positive and negative of battery.
correct.
and since it's like electrostatics law, that means that all electrons have to, or electricity, like follow the same path, or like generally.
Yes, so in
Okay.
any, like for example, if we're talking about the X-ray circuit,
Mhm.
this is basically what's happening in a circuit also.
Okay.
BMT.
So there's no chance for anomaly or anything like that.
There may be. So, to wrap up what we just went over. Electricity, as you probably know, is a flow of electrons through a conductive path called a circuit, right? So batteries have three parts, positive and negative, which is the anode. And in between, we have that chemical solution made up of some sort of electrolytes. So when we hook up the battery to a circuit, what happens is that separation of charges, right? Electrons on one side and the positive charges on one side. So the chemical reactions that's caused by the electrolytes causes the electrons to be built up on this side, the anode side. That's what creates that electrical difference between the anode and the cathode. Okay? And electrons repel each other and try to go to a place with fewer electrons. And where's that place? The cathode. Right? Because if everybody's hanging out here and they repel each other, they want to try to get away, so they go to the cathode. And they don't go straight from here to here, because what's in between?
The electrolyte.
Right, so that's why they need to travel from here all the way around, lighting that light bulb on the way back to the cathode.
So the negative charge that's like on the line of electrolyte and cathode, is that because it's finally made it to the cathode, or is that because it's in the electrolyte? It's a very like
I'm
And
doing a
also-
Mr. Kwan.
Okay.
And ma'am, there's another question.
Yes.
Anode is normally positive, so why do we have a negative here?
Unless they mislabeled the picture,
No, probably not, because maybe there's
or I guess with the battery, the cathode is a positive and the anode's a negative. But let me make sure before I tell you that it's for sure. I don't know if that's just a mislabeled diagram. And so when the circuit is closed, when a wire is connected to both the cathode and the anode, electrons will be able to get to the cathode. Don't look so sad.
But
Oh, I'm just trying to picture it in my mind.
Anyone confused?
so the anode's normally positive?
Say that again?
You said the anode's normally positive?
No. Shaheen was asking me if anode's normally the positive side, why is it labeled as negative here?
In the PowerPoint up there, it also says
I just want to make sure that for batteries, it's like this.
You talking about the
Okay.
I
battery?
just wanna make sure that it's not mislabeled.
So it is like that, the anode is negative on a battery, cathode is
It
positive.
is?
I'm asking.
I want to
It
make
is.
sure that it's
I remember
not
somebody telling you, don't
mislabeled
get
as-
confused
Yeah.
with.
Oh, okay.
And I'll let
Remember
y'all
somebody
know.
said don't get
I'm just
confused
gonna
with.
Google it real quick.
Yeah, just Google it.
Those cation and anion.
Speakers.
Huh?
Cation and anion.
Yeah.
That's what he said. Don't get
Don't
confused.
get confused.
So why am
Anode
I,
is the positively charged electrode by which the electrons leave a device. The negatively charged electrode of a device. It contradicts, the Google definition contradicts itself. It says the positively charged electrode by which the electrons leave a device, the negatively charged electrode of the device supplying the current, such as a primary cell.
let me look this up.
Ma'am, an anode is a negative electrode and it's one of the essential parts of a battery. So it's correct, ma'am.
Okay, so it is correct.
An
Okay.
anode is a negative
Thank you, I
electrode
was about
and
to
it's,
say that.
it's one of the essential part of a battery.
Okay.
It is usually made up of a metal that oxidizes and sends electrons to the cathode.
'Cause
Alright, thank you, Shani.
I always thought of anode as without the positive charge, like without, and then
Yeah, I guess don't relate this to the X-ray tube.
Yeah, just as we know that the anode is always positive and cathode is negative.
Yes.
All this time.
So why do you think I'm going over this basic part of a battery?
So that we do it. in
So that we can
advance,
relate
yeah.
it to the X-ray circuit, right? For X-rays is basically the manipulation of electricity. We use kilovoltage peak, voltage, and we use mass, which is milliamperage. So we use the X-ray circuit for taking X-rays. So for that to be able to happen, there has to be a separation of charges, just like we see in the battery. Okay?
but in the cathode side, aren't we making it negative and firing off electrons? Like in an X-ray? Like, so then isn't it left positive? If we're giving away its electrons?
Making the cathode, so I guess it's making the anode negative, because all of them are gonna accumulate in the anode.
Yeah. But like after we fire electrons from the from the cathodial filament, it like isn't it left positive until we fire again? Because there's energy running through it.
Let me ask Mr. Fong. You know, he's a physics guru.
Okay.
So, so the number of electrons moving in the electrical circuit is called amperage or current, and is measured in amps. And then voltage is the pressure that's pushing the electrons, which is measured in volts. Okay? So when we talk about current, it's measured in amps, and then the pressure pushing the electrons is voltage, measured in volts. And then electricity travels at the speed of light, which is 3 times 10 to the power of 8.
Still don't understand what electrolytes do.
It's a chemical solution that allows for the separation of negatives from the positive.
Does it pass, the electrons pass through it?
No, it does not. Electrons have to travel from the negative side to the positive side within a circuit.
And that's because the electrolyte is naturally negative, right? So that the electrons don't go through it, like bounces and repulses it?
Correct.
Okay.
Yes. So, we can say that we measure electric potential through voltage, and voltage is also, it can be defined as the ability to do work based on that separation of charges. And we already know that current is the flow of electrons within a conductor, and then resistance is the force that resists that flow of the electrons or the conductor. So from that, we have some formulas. So let me go over this first. So voltage, which is measured in volts, that's easy, is the potential difference that will maintain a current of 1 ampere in a circuit with a resistance of 1 ohm. So basically that means one voltage is equal to 1 ampere. What does ampere refer to? Current, or the number of electrons. And it would have a resistance of 1 ohm. So V equals I times R. Okay? And when we use KVP for our techniques, stands for kilovoltage peak, that represents the highest potential difference within the two. So the highest potential difference between those charges is represented by KVP.
Yes, the peak, has potential difference.
V is equal to IR. You said I was what, ma'am?
I is the amperage, or the current. I'll show you the formula in just a second.
So then KV would just be the potential differences?
Correct.
Okay.
So voltage is kind of like the pressure that exists in a conductor. Okay? Amperes, the amount of current flowing with a potential difference of 1 volt in a circuit with a resistance of 1 ohm. So the number of electrons or the flow of electrons depends on various factors such as the material that is attempting to flow through. So if it's a very good conductor, you're gonna have a lot more electrons flowing through, so a lot more current. So current can be described as kind of like the size of the hose. If you were watering your garden, if you had a very thick hose, you would have a lot more water coming out, correct? And if you had a very narrow hose, you would have very little water. Y'all look so bored.
So then it comes down to like pressure and how fast or
Yes,
how much
all
water
of that
comes out.
affects each other.
Okay.
The pressure, the current, the resistance, all of that affects electricity.
Amps is represented by A or it's represented by I. Is that what is meant by that?
So amperes unit is represented by A,
Or I?
but in the formula it's I. So let me see.
What size matters?
So V represents the potential difference in volts.
What?
I in the formula would represent the current in amps. And then R is the resistance, which the unit for that is ohms.
Sorry.
I know this is not exciting stuff.
Nope, it's not. We're not gonna lie to you.
Do some yoga to wake some people up.
We're gonna leave a lot of.
I know, I should do like Mr. Brown. Alright, everybody stand up.
Yes,
Stretch.
thank you very much.
Do you hear it? Yes.
So the higher the voltage, which is the pressure, the higher the amps, the number of electrons flowing.
Correct.
The higher the voltage or the potential difference, so the pressure, then the higher the number of electrons flowing through the conductor.
Everything high. And
Not
it's-
everything.
Amps is electrons, voltage is pressure. That's what I think my sister's saying. Okay.
Volt is the pressure that you're putting in, and then the number of electrons, the amps. So it'll increase the number of electrons.
What is not considered high?
So I guess like when you're turning on the hose, like you turn on a little bit, it's not that much pressure.
Right.
So not that much water is gonna come out, but if you turn it open all the way, then you have more pressure coming in and more water coming out.
Got that pressure?
Until we have our resistance.
Resistance.
Peace.
Which would be the
Twist the
like the outlet
the
size.
hose and create a resistance.
Oh, so it's fighting you.
So resistance
That's what it
is
is.
kind of like if there was some sand in your water hose,
Like a
which
block.
prevents, yes,
Like it blocks it.
yes.
Okay.
Which prevents the water from actually flowing through.
Or more accurately, one of those could be
Like, you know how it freezes
powered up
during the
or
winter?
Yeah,
it's
it's kind of
normal.
That's what I was thinking.
And that would be
Twisted.
resistance.
A key.
Oh.
Not that. So, resistance is measured in ohms. So it's a property of a circuit that attempts to prevent that flow of electricity from happening.
So could that also increase the pressure? If you
More
like
resistance
reduce,
increase the
Mhm.
pressure.
Decrease.
because if you didn't change, so like then how does, if you pinch your water hose instead of keeping it, it shoots out, doesn't it? If you don't change
It
current, if you don't do anything,
The flow.
you're not necessarily letting out more electrons, but you're increasing the pressure of which it escapes. So you put your finger in front of the water hose and then beam
I get what
changes.
you're saying,
Okay.
yes. Let me come back.
Okay.
Jesus Christ. Well, this is within the hose.
Yeah, but you're still doing that within the hose, you know what I'm saying? Like it hasn't escaped yet. You're just adding a little ring to it.
I think this is just talking about like you're gonna obstruct the hose.
Thank you.
It's gonna,
That's exactly what it's talking about.
it's gonna decrease the pressure.
Accurate ones.
Relax, Charles. Damn. Right.
I'm sorry, baby.
God, drink
like
more
cats
coffee. Who switch out your coffee with water today? Trying to be healthy, taking it out on me.
Vehicles are.
So velocity equals image receptor?
Miss Bonilla, I'm just
No,
going with
it's-
y'all.
No, I'm looking
It's
something up.
reality.
Leave me alone. V equals potential difference.
Okay, so Ohm's law, which I forgot to include in those slides, my
Let's talk
bad.
about Ohm's law.
It says that current is directly proportional to voltage, which Nancy just said,
But
and
inverse.
it's inversely proportional to resistance.
Mm.
Okay?
I knew
Why
that.
are you so excited?
Because that's what I was saying.
No, you didn't.
No,
that's not
It
what you said.
was, no, because you're
Repeat that
reducing
again.
resistance.
Current is
It's
directly
directly
proportional to voltage, meaning
Right.
more voltage, more current, more
Right.
current, more voltage.
But if
But current is inversely proportional to resistance, meaning if you have more resistance, current goes down, so that makes sense.
I'm not, but I wasn't.
You're stopping the flow, so that's why the current's going
I-
down.
I wasn't saying that the amount of the water gets reduced. I was saying that the pressure, like the intensity of the water, is
No, it's the
increased.
same pressure, you just don't take it off and release the pressure.
Ms. Bonilla, you said more voltage,
Yeah.
more current,
Say that again?
more voltage, more current.
Yes.
And
But
then-
if there's more resistance, your current and voltage goes down.
So it decreases.
Mhm.
And you said, voltage is the pressure,
Yes, it's kind of like the pressure within that
Got
conductor.
that pressure?
and then current is,
The number of electrons that's flowing through.
You did this one?
Alright, so that brings us to our formula here, V equals IR. V is our potential difference or our voltage measured in volts. I is our current measured in amperes or amps. And then R is our resistance measured in ohms.
ohm.
It's not that old.
I need to leave. They said they got a recall on my car.
You call
On my car.
your car.
On her cart, like
Alright,
her,
moving on.
Oh.
her cartridge.
Where's radio?
She went to the restroom.
She was experiencing that current and resistance, you know what I'm saying?
She's big out
She
there.
was having that voltage.
She's like, I gotta go, y'all.
I got a picture the whole day she had.
No, 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 no.
It's okay, we're still in the.
Alright.
Mr. Black, you looking at the camera?
That's up the same.
Yes, yeah, that's horrible.
If the current is 2 amps and the resistance is 10 ohms, what is the voltage?
5.
Well, what are we gonna do? Tell me how you
Oh,
got
2
the
times
answer.
10.
2 times 10, because V equals IR. Super easy, right?
Is it?
Yes.
I just can't stop thinking.
What about this one?
You're
If the potential difference is 10 volts and the resistance is 2 ohms, what is the current?
Come on, why you
So
trying to
how
make
would
me
you
do
get
something
that I
different?
by itself?
This is
So
wrong.
you would V over R.
I mean, 2?
Yeah, volts over ohm.
Divided by 2, so 5.
Oh, that was a
I.
I thought it was a one.
Yes, V divided by R. Don't worry, Taro, I'll bring you some worksheets next time.
And then A is amps, right?
Yes.
Okay.
If the potential difference is 230 volts and the current is 10 amps, what is the resistance?
230 divided by 10.
Okay, so how did you get your R by itself?
Separate is the I.
Divided by
Divided by
10.
I. V divided by I equals R. Got it?
And the whole test just not.
I want to stop there for today.
Yes, thank you.
I don't want to tell you